Okay, so now let's take a look at page number 2. Number 6 says identify which is a function and which is not a function. Explain in words why or why not. State the domain and range also. Okay, so this first one would not be a function. And the reason is this does not pass the vertical line test. If I draw a vertical line through this graph, notice that it hits 2 points on the graph, which makes this not a function. So why or why not? The graph does not pass the vertical line test. I'm going to abbreviate it as VLT, vertical line test. Okay, so take a look at the domain here. So when we're thinking domain, we're thinking x values. So how far left does this graph get? How far left does this graph get on the x-axis? So it looks like it reaches -3 and it touches -3, so I'm going to use a bracket. And then how far right does this graph get? So if I look how far right this is going, I notice these are arrows, which means they're going to continue on forever. So it's going to go right to positive infinity. Okay, so now let's take a look at the range. When I'm thinking about range, I'm thinking the y values. So how low does this graph get to how high does it get? Okay, so I see an arrow pointing down, which means this goes down and right forever. So this range is going to start at -infinity, and it goes up forever, so it goes to positive infinity. So there is my domain and range for number 6. So now let's look at number 7. Okay, so number 7 is a function. The reason is it does pass the vertical line test. So for every x value, there is exactly one output value, and I know that because if I draw my vertical lines through this graph, it only touches 1 point at with each line. Okay, so why or why not? The graph passes the vertical line test. Again, I'm going to abbreviate that VLT. Okay, so now I want to think domain. So domain means how far left is this graph getting? And I'm thinking x values. So I notice I see this arrow, which means it continues left forever. So it's going to start at -infinity, and it goes right forever also. So it goes to positive infinity. And same thing with the range here. So if I look at this graph, it goes down forever. And now I'm thinking about y's. So this graph goes down forever and up forever. So I'm going to start at -infinity and go to positive infinity. Notice with my domain and range on both these examples, the smaller value is always the first number, and the larger number is always the second value. Okay, so now let's take a look at number 8. So number 8 says if f of x equals 2x squared minus 3x plus 4, find the following. So basically it's telling us to evaluate f of x given x equals 0, x equals -3, x equals 2, and x equals 1/2. So what we're going to do is we're going to substitute 0 in for x into our problem wherever we see x's. So what this will look like, we'll have 2. We always want to substitute our value in its parentheses times 0 squared minus 3 times 0 plus 4. I'm going to type this directly in the calculator to evaluate this. So I have 2 parentheses 0 squared minus 3 times 0 plus 4. So when I do that, I get f of 0 equals 4. So let's take a look at b. Now I'm substituting -3 in for x. So when I do that, I have 2 times -3 squared minus 3 parentheses -3 plus 4. Make sure, especially with the negative numbers, that you substitute these in with their parentheses. That's very important. Okay, so I have 2 parentheses -3 squared minus 3 times negative 3 plus 4. And when I do that, I get 31. So f of negative 3 equals 31. So now let's take a look at C. It says find f of 2. Okay, so now I'm going to substitute 2 in for x. So let's find another color. We have 2 times 2 squared minus 3 times 2 plus 4. And then I go back to my calculator. And I get 6. And then last but not least, I'm going to substitute 1/2 in for x. So when I do that, I'm going to have 2 times 1/2 squared minus 3 parentheses 1/2. Sorry, I'm running out of room here. Plus 4. And then I go to my calculator. So a quick reminder, if you're trying to remember how to type fractions into the TI-84 calculator, you go to alpha, which is the green button. You then click y equals, and you click enter. It gives you a fraction, and you can put your numbers in there. So when I do that, I have 2 times 1/2 squared minus 3 1/2 plus 4. And when I do that, I get 3 as my answer. Okay, and then last one for this page is number 9. So which of the following relations are not functions? Which are and why? So number 9 is a function, and the reason is for every input so remember, our inputs are these numbers, and our outputs are these numbers. Okay, so for every input, for number 3 and 4, there is exactly one output. So each one of those numbers 3 and 4 are paired with just one number. Okay, so my domain is my domain are my inputs, or my x values. So my domain is 3 and 4, and my range is 11 and 15. Okay, so let's look at the second example in number 9. Is this a function? Yes or no, and why? It is not a function, and the reason is because 7, one of my input values, so 7 is paired with 2 output values. So 7 is paired with 2 output values. So your x is never allowed to be paired with 2 different numbers. A quick way to think about this is if you ever see 2 arrows coming from the same number, you know that this is not a function. Okay, so my domain here is -4 and 7, my x values. And my range is 2, 5, and 9. And I use the set notation brackets. Okay, and then last 2. So just quick glancing at this, you may think this is not a function, but it actually is a function. And why or why not? Because for every x value or input, there is exactly one output. Okay, so they all have the same output, which is fine, but there is just one output for each of these. You don't see 2 arrows coming from the same input value. So this is a function right here. My domain is -2, -1, 0, 1, 2, my x values. And my range is just one number. My range is 5. Okay, and then last problem. So, function or not a function, this one is a function. for every input, there is exactly one output. So each one of these input values is paired with just one number. So -4 is just paired with 16, -3 is just paired with 9, 3 is just paired with 9, and 4 is just paired with 16. So this is a function. My domain, again, is my x values. So in set notation, it's -4, -3, 3, and 4. And my range is my y values, and it's just two numbers, 9 and 16. Okay, so this concludes the second video. I will go back and make the next video for the third page. Thank you.